thanks for having me, first of all. I'm very much looking forward to discuss with you guys the chances of mobile mapping that it brings to our industry actually today, but also in the future. So when we want to look into the future, it's always a good idea to look a little bit back into the past of where things have been and how they have actually evolved. And as you know, since the 1990s, digital toll stations brought us quite some improvement in our work, right? So we were able to measure directly distances versus we had to triangulate only before. And that by itself allowed us to be a lot faster, a lot simpler in the application of it. In 20 years later, we saw terrestrial laser scanning system becoming the basically standard tool in the industry. Yet, many people in the 2010s were really saying like, oh, the digital toll station is actually good enough for my jobs, for the majority at least of my jobs. And in theory, you can even convince yourself that a terrestrial laser scanning system is basically just a faster digital total station. It's basically just less accurate, right? So is that why it actually did get so much attention then in the end? In reality, a terrestrial laser scanning system is so much more than just faster. It's more comprehensive. It is a simpler solution to the majority of applications that you typically have. And so when you talk about comprehensiveness, it's basically sometimes looked as like a nice to have. But in reality, it really means floor flatness, it means pipe diameters, it means so much more value for so many more applications. So I say this because I'd like to remind ourselves about the fact that pretty much any breakthrough technology at the beginning will ultimately face some skepticism. And the skepticism will prolong until basically everybody has invested into it. So now you've seen terrestrial laser scanning systems becoming widely adopted, and they had quite some innovations in the early 2010s, becoming better, more accurate, and so on. But now, since the last few years, they are very similar to each other. They have the same accuracy almost, the same size. And the thing that you will probably most anticipate when a new terrestrial laser scanner comes to the market is that it's actually lower in price, so a little bit cheaper then. And this becomes more and more saturated these days. But there's one thing that all of those terrestrial laser scanner systems have actually in common, and that is a very fundamental limitation. And this is that you have to be static while you're scanning the environment. So that means that if you're looking into a project, you have to actually merge scans, multiple scan stations together, and only that will give you actually a precision of the whole project. And so these scan-to-scan matching techniques are extremely important, and at the same time, the way how you set up those scans, where you place them. And probably a couple of you that are very experienced will probably say like, yeah, George, nice that you show these setups, but you could do it even better, right? You can place those static scans actually in the door frame, so you're better off. It just proves the point that it's so much more important to be experienced than to have the most precise laser scanner. Just 1 millimeter in a scan doesn't make a difference for the overall project in the end. And so when the last 15 years haven't really shown a drastic improvement in terms of speed, comprehensiveness, and so on, to be again much faster and more comprehensive and to attract more applications, there is one logical step on how to evolve further, and that is to be mobile, to be able to scan as you move through the trajectory, with the trajectory, through the space. So it's a logical evolution actually from a total station over a terrestrial laser scanning system to a mobile mapping system. But now the question obviously appears, why wasn't this actually offered in the past? Why wasn't this available? The reason is that terrestrial laser scanning providers in the past have been extremely good in creating the very best hardware, the very best lasers and lenses maybe. But the core of every mobile mapping system actually is software. Software that allows you to precisely estimate the trajectory as you move through this environment, and at the same time create a 3D digital twin, or basically a 3D copy of that environment. And simultaneous localization and mapping, SLAM, is just one piece of this overall software suite that really have to be brought to perfection. So just to repeat again, mobile scanners are much less relying on the best possible hardware like lenses or lasers. They are much more relying on an amazing piece of software that is continuous to improve as you basically use this device, whereas lenses and lasers are of course frozen, right? You buy them and then this is the thing. So let's understand this a little bit more into depth. So as I said, laser scanning has been in the past purpose-made, precise pieces of hardware, and they have been obviously very expensive as well. Meanwhile, laser scanning becomes much more of a wide adoption in the robotics and into the autonomous driving industry, where we see more and more of those scanners being used. And at the same time, those scanners need to be a lot more holistic. They need to see a lot more. There's not just one single pointer that is pointing and scanning the environment, but it's actually multiple laser beams that are capturing the environment and in the same time, extremely comprehensively. Now, however, there's also a disadvantage to those scanners that basically have higher noise, which is in the range of 3 centimeters, and obviously that is not good enough for surveying applications. But this is exactly where NavVis is excelling. So we are able to get from this comprehensive, massive amount of data, the exact whereabouts of these environments, and are able to extract through SLAM and AI data fusion a lot higher accuracy than anyone else from this data. And maybe after this presentation, I can bore you with even more details about how exactly that works, but this is really at the core of the software. And it's to some extent also a little bit similar to what you know from, let's say, software-defined imaging, where more and more in today's most or the best cameras, the software is playing a dominant role, not the size of the imaging sensor anymore, but really the software that is driving the sensor. So to put it back together, if you ask any vendor here at Intergeo, and if they're honest with you, what is going to be the driving force behind the next evolution of reality capture, then they will tell you it's software. It is software that drives the next evolution of laser scanning. And now in this slide, I think it becomes pretty apparent that mobile mapping systems allow you to map a lot more per project and per person than it was ever possible in the past. And this, of course, allows business to grow drastically. And as a matter of fact, pretty much all of our customers were able to scan twice as much as they have ever scanned in the past, thanks to the VLX and the services that they put on top of that. So now a VLX owner, many of our VLX owners actually easily capture more than 400,000 square meters per year per device, and a few do actually some more than 1 million, actually 2 million square meters is something that we have seen already. Now you can calculate the return of invest for that kind of application for you. So now to bring it back together, while the first mobile scanning systems were available as early as around 2009, the real widespread adoption actually happened in 2019 or 2020, when these first devices reached an accuracy level that is below 10 millimeters, something like 6 or 8 millimeters of accuracy. And that was, of course, a breakthrough. Now, of course, I would like to emphasize that this is not a play of a total station versus a TLS versus a mobile mapping system. All these three are perfectly combined, especially in complex applications, where it's, for instance, that the VLX can pick up control points surveyed by a total station and bring point clouds from a drone or a terrestrial laser scanning system together and then to be compared against, for instance, a BIM model. And so we absolutely acknowledge that all of these systems are absolutely necessary and it's the right tool for the right task. But so much about the theory. Well, let's have a look if that's actually all true, that these accuracies and qualities have been reached already. Now, what I brought here with me, and maybe this crowd can get a little bit more interactive, so to make it a little bit more enjoyable, is that we have two scans. And what I would like to know from you is like which of those scans is actually mobile and which is a terrestrial laser scan. And I hope you can actually spot the difference. We didn't make it too easy. I hope at least that you cannot see circles or something typically for a terrestrial laser scanning system on the ground. But I hope that you can see actually the difference. And let's see if you can. Two very nice scans, one in Stockholm, the other one actually in Munich, Königsplatz. So as you look at these details, maybe it's already a little bit like an idea of what it is. So maybe I can already start asking. So and like, please dare to raise the hand. There's nothing that you can do wrong here. So who thinks that on the left side this is a mobile scan? Anybody? 2, 3. Okay. So who thinks on the right side this is a mobile scan? Okay. Yeah, 4, 5. Okay. So the good thing is you're all right. It actually both is actually done with the VLX. So both VLX scans that we have done. And you see basically how much this has already progressed in the last few years. Now, this is obviously visually, right? But what about the numbers? So to do this in a good and confident way, what we have done is we scanned around 600 square meters in our office. And we did that, first of all, with a terrestrial laser scanning system. We did that even with a total station to really be sure that it's ground truth data. It took us actually 1.5 hours. That is not how long it would usually take, probably maybe an hour or something. But this is about the time that it took us to generate this ground truth. What we've done then is to scan the very same environment with the VLX. And it took us, the 600 square meters, it took us 6 minutes to map that. So it means like 600 square meters in 6 minutes, right? That's an enormous speed up. It's like hard to match with anything. I would definitely say it's something like a world record. But then, okay, you can do a lot of things in short amount of time. But what about the accuracy? And the accuracy of this project has been 6 millimeters. So if you compare these two scans with each other, you will actually see that the deviation is just 6 millimeter. So it's lower than 6 millimeters, obviously. So here you actually see the scan that we have done with the VLX in just 6 minutes. So as you can see, it's quite comprehensive. Look at the staircase, the details of those handrails and so on. And what I will show you next is basically that we have taken 2 sections. And these 2 sections were now compared with each other so that you can hopefully better see visually. This is the TLS, and now this is the VLX overlay, and you see they are perfectly matching. With a naked eye, it is extremely hard to see any difference. You can look up the video online, so you can really zoom into the details and see if you see a difference. There are differences, like for instance here, where things have changed over time, but other than that, you only see it at the tiny edges, right? Where we basically are just a few millimeters off, because this laser scanner that we used is really the best in class. You cannot be more precise, and yes, that's why I'm saying there are still complementary natures. But again, 6 minutes, this is how we have done it. We were just walking through this environment. We did not take any control points to artificially improve the accuracy or anything, just the 6 minutes, that's it. And then we compared those 2 scans with each other through ICP registration. Check out the video online, you see how the live interface here shows you what you have scanned and what not. Then the question really arises, so what does it mean for us? Is it just about reducing the time, and is it about reducing the cost? And the answer is, of course, no. It is very similar to the internet. Because in the early times of the internet, like a kilobyte was already, you could even put a price tag against this, right? And it basically shows you like people are spending these times not less for the internet, because per kilobyte it became a lot less expensive. They are spending actually more for the internet, and more applications came on top of that, because the price per unit was coming down, because it was more accessible for a lot more applications. So what I show in this chart is basically that the cost per square meter will eventually decrease. This is nothing driven by us. This is just the nature of the beast. You cannot stop it. We cannot stop it. It's just happening. Even if we would not have any new technology, still static scanning, you see the prices coming down. Those systems are getting a little bit more efficient. This is something that eventually will happen. The question is only what are you doing with that trend? And in the end, what is the good thing about it is that on the upper part, you see the number of use cases and projects that are associated with a certain price point. And as the price point comes down, more use cases have a profitable return of investment, so that your clients will say, yes, this makes actually a lot of sense. And this is also driven by mobile mapping. So you see that more and more scanning or reality capture is used for high-value processes like factory planning or construction planning. And it goes further into everyday usage for a broad variety of tasks like construction management, facilities management, so where you have much more frequent, more scans. And this is exactly where the future of reality capture will go. And this is not even the end of the spectrum. We will see that there is more and more technologies on the verge. Some of you will probably have already seen there's autonomous scanning at the verge of just being shown to the public in first prototypes, where in the end you have a high frequency scanning in the end that allows you to continuously have a almost real-time representation of the as-is conditions. And then basically what today you're saying, like, this happens without any manual intervention. Of course, this is not true, right? We all know that you have to stand next to the doggy and use the joystick to control it, right? So basically this is really just for the visionaries in the moment to see where this is going. And it's basically something that still is going to happen no matter what. The question is really just how we are going. Today, however, is the year of mobile scanning, where this is basically having the impact on our market. But let's look again into the applications as to close this presentation. So we basically see that today, many of you are already working on as-built documentation, and I'm pretty sure you use terrestrial laser scanning for that, because you get to see so many more details, so many more insights about how this building is. You can give these point clouds meanwhile to your customers. They're able to understand this. They can use the software to extract the information from that. So it's becoming more and more valuable. And thanks to mobile mapping, you can apply to smaller and smaller projects and still be profitable and just do a couple of those houses per day. Because you can just go in a house, you're done after half an hour latest, and then you just hop onto the next project and just do it. So it's like the amount of projects is just drastically increasing, and you can also, thanks to the comprehensiveness of the data, not just be fast, but also provide real insights into how the things actually look like, have a panoramic image everywhere. Second, construction verification. This is something where I believe the terrestrial laser scanning system was only used as the exception, not the rule. What you want to do is to really understand the difference between what is currently the state, the as is, and what have I actually planned, to find those mistakes very early on before you actually build something on top of that where the cost of solving that or removing that problem are actually drastically reduced. Yeah? When you wait longer, it just takes a lot more money, obviously. So you need to detect it very early, and this is exactly now what you can do with mobile mapping. Now the costs per scan are coming so far down that it's actually very profitable to solve those mistakes early on by recognizing this, by comparing the as-is with the 3D model. And this is exactly what's already happening. A lot of companies like Immerso and Doxel, for instance, are providing perfect software, like also partners like ClearEdge from us. And you see more and more customers that are applying that. So lastly, factory planning. Again, something that has a big trend these days, where more and more factories, plants, logistics centers need to know how things actually look like so that they can remotely bring the experts together, so that they don't have to travel and exchange in an analog way. And to plan how things are supposed to be obviously requires how things look today. And this is of immense importance for them. Still, they are not able to support or actually finance a scan that is happening 2 or 3 times a year for that application. With mobile mapping, however, they are. They actually do this, and they do this extremely often to be able to bring those people virtually in a meeting on site and to discuss this. And of course, this also has a big impact on sustainability, to allow the people not to use an airplane to find out what's going on in their site. So there's a lot more applications that I won't be able to talk about, but yeah, more than happy to get any questions about this. Thank you very much. Thank you.